Tonight, the moon will begin to disappear. Not because it moves away, not because it burns out, not because something swallows it, but because Earth itself will block the sun. Slowly, a shadow will creep across the moon's surface. The bright silver glow will fade. And then something extraordinary will happen. The moon will turn red. For thousands of years, humans looked at this moment with fear. They called it an omen, a warning, a sign from the gods. But the truth is far more powerful. A lunar eclipse is not magic. It is geometry. It is gravity. It is cosmic alignment. And tonight, we're going to explain exactly how it happens. What is a lunar eclipse? To understand a lunar eclipse, we need just three objects: the sun, the earth, and the moon. Normally, sunlight hits the moon directly, which is why it shines at night. The moon doesn't produce its own light, it reflects the sun. But sometimes, the alignment changes. When the earth moves directly between the sun and the moon, it blocks the sunlight. Earth casts a shadow into space, and if the moon passes through that shadow, we get a lunar eclipse. Simple in concept, extraordinary in scale. Because that shadow, it stretches nearly 1.4 million kilometers into space, and when the moon enters it, we witness a cosmic shadow play. Why doesn't it happen every month? Here's something interesting. The moon orbits the Earth once every 27 days. So why don't we get a lunar eclipse every month? Because the moon's orbit is tilted by about 5 degrees. That small tilt makes all the difference. Most months, the moon passes slightly above or slightly below Earth's shadow. The alignment isn't perfect. For a lunar eclipse to occur, 3 conditions must happen. It must be a full moon. The moon must be near one of the 2 orbital nodes, where its path crosses Earth's orbital plane. The sun, Earth, and moon must line up almost perfectly. When that alignment happens, the shadow falls exactly where it needs to, and the eclipse begins. This is why eclipses feel rare, because perfect alignment is rare. The shadow of the Earth. Earth's shadow has 2 parts, the penumbra and the umbra. The penumbra is the outer, lighter shadow. If the moon passes only through this region, we get a penumbral eclipse. It's subtle, hard to notice. The umbra is the darker, central shadow. If the moon passes fully into the umbra, we get something dramatic, a total lunar eclipse. This is when the moon darkens completely, but it doesn't vanish. Instead, it turns red. Why does the moon turn red? This is the most fascinating part. When Earth blocks the sun, you might expect the moon to go completely black, but it doesn't, because Earth has an atmosphere. As sunlight passes through Earth's atmosphere, something happens. Blue light scatters in all directions, red light bends and passes through. This is the same reason sunsets are red. During a total lunar eclipse, Earth's atmosphere acts like a lens. It bends red sunlight into the shadow. That red light travels across space and softly illuminates the moon. So when you see a red moon during an eclipse, you are seeing every sunrise and sunset on Earth projected onto its surface. It's not a blood moon, it's filtered sunlight, a global glow. Types of lunar eclipses. There are 3 main types: penumbral lunar eclipse, partial lunar eclipse, total lunar eclipse. In a penumbral eclipse, the moon passes through Earth's outer shadow. It dims slightly. In a partial eclipse, part of the moon enters the umbra. A dark curve appears on its surface. In a total eclipse, the entire moon enters the umbra. This is when the red transformation happens. Each type depends on alignment precision. Cosmic geometry determines everything. How long does it last? Unlike solar eclipses, which last only minutes, lunar eclipses can last hours. Why? Because Earth's shadow is much larger than the moon. The moon moves slowly through that shadow. Totality, the red phase, can last over an hour. From beginning to end, the entire event may take 3 to 4 hours. It's a slow transformation, a gradual cosmic event, not a sudden disappearance. Where is the best place to watch? One of the best things about a lunar eclipse, you don't need special equipment. No filters, no protective glasses. If you are on the night side of Earth and the moon is above the horizon, you can see it. The best viewing conditions? Clear skies, low light pollution, open horizon. Unlike a solar eclipse, which is visible only in a narrow path, a lunar eclipse can be seen from half the planet at once. Entire continents can watch together. It is a shared global experience. History and fear. Before science explained it, lunar eclipses terrified people. Ancient civilizations believed a dragon was eating the moon, the gods were angry, a king would fall, war was coming. In some cultures, people made loud noises to scare away whatever was devouring it, but the moon always returned, predictable, reliable. Eventually, astronomers realized something powerful. If you understand gravity, you can predict eclipses centuries in advance. What once inspired fear became proof that the universe follows rules. The science of alignment. At its core, a lunar eclipse is a demonstration of orbital mechanics. Gravity pulls the moon around Earth. Gravity pulls Earth around the sun. These motions are stable, predictable, but only occasionally do they align perfectly. When they do, the shadow falls exactly where it must. It's not coincidence, it's physics. The eclipse reminds us that we are part of a moving system, a dance of massive objects in space, and sometimes that dance lines up just right. Why it matters. A lunar eclipse does not change Earth. It does not alter gravity. It does not signal disaster, but it reveals something profound. It shows us the scale of our place in the cosmos. The Earth large enough to cast a shadow into space, the moon close enough to drift through it, the sun distant enough to illuminate it all, and us standing on the surface, watching, understanding. For most of human history, we feared eclipses. Now we predict them, study them, photograph them, share them. What changed? Knowledge, understanding causality, cause and effect, alignment and shadow. A lunar eclipse is not magic. It is evidence that the universe operates by laws. And when those laws align, we witness something beautiful. The next time the moon turns red, look up. You are seeing sunlight filtered through Earth's atmosphere, bending across space, illuminating a world 384,000 kilometers away. You are watching gravity, geometry, and light interact. you are watching alignment. A lunar eclipse is not the moon disappearing. It is Earth revealing its shadow. And in that shadow, we see how everything is connected. The sun, the Earth, the moon, and us.